Oops, I think I definitely got the wrong data set here. So let's download this. Let's upload it. Hope I got the right one here. You just normally double click to open it in Excel, you know. Oh, man, it's still doing sepal length. In the third sheet, oh, it's in the third sheet. So I did have the right data set. So the sheets are usually on bottom in Excel, or I'm on Google Sheets. There's systolic blood pressure they're talking about right here. Okay, so I got what they're talking about. Let's see. What is the equation for the least squares regression line where the x variable is age? So this is our x variable. And the dependent variable is systolic blood pressure. That's our y variable. So for a least squares regression line, we need a slope. We need an intercept. The slope, you type equals slope, open parentheses, and it goes y variable first. So it starts on C2, and then it ends on C31. So put a comma, and then the x variable, B2, colon to B31. You can click and drag those too, like I've shown in other videos. Same thing with the intercept, like we've done in other videos. This is C2 to, I forgot what the number was, C31. That's supposed to be a colon. C2 colon C31, comma, B2 colon B31. It's got to be the y variable first, or else it's not going to come out right. So the slope is always the number next to the x. So our slope is 0.97087, and the y variable is 98.71472. Patient 12 is 56 years old and has systolic blood pressure 150. What's the residual? So the residual is talking about how far off your prediction is. So what you do is you plug in the x variable to predict what the y variable is first. And we said our x variable was age, right? The independent variable is age. So we're predicting when x equals 56. And to do that, all you have to do is plug in 56 into your regression equation for x. So there's our x right there. 56 goes in there, and x is right next to the 0.97, so you have to multiply by 0.97087, and then add the intercept, the 98.71472. So that's what we're predicting for our blood pressure. Now that's not the residual though, that's our prediction. We predict this. What we want to do is we want to compare it to an actual value. We patient 12 down here, 56 years old, their actual blood pressure was 150. So the residual is how far off it is. Okay? You take your prediction, subtract it by the actual value, and that's your residual. Okay? That's what goes here. Just make sure you have that order right. Your residual should be negative if your prediction was below the actual value. Your prediction. Let me think about that actually. Here, I have that. I actually think I have that backwards. 1 second. A positive residual means it's an above average value, and the values you get from your regression line are the average values. So mine should actually be negative. So I'm glad I stopped to explain that because I realized I made a mistake. So here's the formula. Just so here's what you should do. You take the observed value and subtract it by the predicted value. That's how you calculate a residual. We observed 150 for this patient 12. We predicted 153. So if you subtract those into your calculator, you'll get the negative value. So if you always stick with this, that will calculate your residuals. Is it above, below, or on the line? It's negative, so that means it's below the line. What is the interpretation of the residual? It's a difference in the actual and predicted blood pressure for a given age. Yeah, that's what it is, right? These are blood pressures. It's the difference between the actual and the predicted blood pressure. It's not that we didn't do any calculation with age. We didn't subtract or add ages. Okay, I think that's everything for this problem for 2.3, unless there's something else. That's everything. Okay.